Okay, started the recording. Okay, a little recap. So this is what we saw about the framework. We understood like what this is Hadoop is one of the solutions to deal with a large amount of a data, big data. So this is an analytics part. It will also do storage and analysis. Storage is done using the in Hadoop. Storage is Hadoop is actually having two components. So one component is the Hdfs, which is a file system which helps us to store the data, large amount of data, in the form of a file structure itself, and MapReduce is the processing unit in Hadoop. So how it is layered in our computer, this is how it is there. So along with that, other any applications are like MapReduce is an application, Pig Hive, anyone can connect with the Hadoop framework and process the data. Okay, they can also use the Hadoop framework to store the data. Okay, they in the sense these are the application which I am talking about. Then we saw like what is an HDFS. It looks like a file system itself. It is a file system itself to store the data in your a distributed environment. So you can store, you divide the data in the form of a blocks. Data in the sense or files, whichever we are storing, they are divided in the form of blocks of block size 128 MB, which is the standard one, which is again configurable, that you can configure in your hdfs site.xml, that configuration file. And that it gets replicated based on some algorithms they use, okay, to do the replication internally. Okay, based on that it will gets stored in different data nodes. So data nodes is the one which stores the data, and HDFS is the distributed file system which provides us the facility to store the data distributedly. Okay, so how the blocks are stored, the how the blocks are stored, which data node it selects, which racks it's present, it is like an algorithm. Okay, they take some combination and permutation and combination, and that way they will store it. Okay. Mm, and furthermore we saw like how a client will communicate with the name node. Name node is the master node. Okay, so the processes which are running, which is nothing but the name node process, secondary name node process, the data node process, and other two processes like a resource manager and node manager process. Okay, the client will communicate to the master using the name node process, and then it gets the information about where the blocks are present in your rack or in your data node. Okay, and then it will directly communicate to the data node, and to retrieve the data, or in order to write the data into the data node. Okay, retrieve the data after the processing. Say here we can think of like the applications which are going to do the processing as a client. Okay, like a map reduce application, map mr, I'm writing it in small, map reduce application, or a pig or a hive, all are this we can consider it as an applications. Okay, so in the name node what all things will be there that we have seen is that it contains the hierarchy of the uh, it contains hierarchy, I mean the file structure hierarchy it contains, and where the data nodes are present it contains. Name node only is, name node is the node which will decide where your data should go and sit, in which data, in which data node your data will go and present. Okay, that will be decided by name node. That day I told as a yarn, not, it is not yarn, it is a name node. Yarn will take care of the resources. Resources means like a memory resource, that is hard disk resources, cpu resources, cpu utilization, okay, memory, and all this about the resource management that will be taken care by yarn. Okay, where the data should present in the data node, in which rack or in which data node it should be uh, it should be put, and it should be replicated, all are all taken care by the name node. And it also stores this information like about the file system information, file structure information. File structure information means, say for example, if I'm storing a file, sample.txt, that it is stored in data node 1, 3 and 4. Okay, so this information, like a sample, if this is divided, it is divided into 128 mega blocks, and it is stored in one part. Say for example, uh, three parts if you are dividing it. Okay, or if it is divided into two parts where it is stored in one and it is stored in three. Okay, here it is stored three in data node and four data node. All this information will be present in the name node itself. Okay, so the client which communicates will contact the name node, get the information like where the data is present, and then do the processing on that data. Okay, processing means any code which we are writing for doing the processing, for analyzing the data, will be put in the data nodes and it will do the processing. Okay, and the replication information also, like if one is replicated in data, say this is data node 1, this is data node 2, data node 3, data node 4, then a part of, if 128 megabytes is divided into three parts, sorry, sample.txt is divided into 3 into 128 bytes, if you think like that. Okay, then if you are doing a replication factor, this uh, it is divided in three segments of 128 bytes and stored in data node 1, 3 and 4. And we also say that it is replicated thrice, right? Then it can also store this one here. It can also be stored one here. Okay, three times it is replicated. The remaining, what do I, how I say, like this is sample one here, sample one here is stored, and sample one here is stored. Okay, three times it is replicated. And sample two, say for example, it can be stored here, it can be stored here, and it can be stored here. And sample three can be stored here, sample 3 and sample 3. So all this information, like node data node 1 is having a sample part 1, that is 128 bytes of a sample file 1, and sample file 2 it is having, data node 2 is having sample 1 and sample 2 and sample 3. Okay, and data node 3 is having s1 s3, and data node 4 having s2 s3. Okay, all this information is present in the name node itself. Okay, in where it is present, this the complete information about the file structure divided, everything is present in the fs image. Okay, fs image file, this is an image file. Okay, fs image file. Yes. Yeah, by default, this replication fact, it is divided into three, means three nodes are there, three data nodes are there. Three data nodes are, you can say, even the master node, you can, here in our case we will consider it as a data node. Okay, otherwise data node will be master node and data node will be separate. Master node, that is the name node, will be separate and the data node will be separate. Always by default, see, they have replicating thrice is enough. Okay, even the understanding is, even if two nodes, see s1 is present in s in node 1, 2 and node 3. Say for example, at the max, if two node goes, this complete data node is down and this node is also down, you can retrieve the data from s1. Okay, it you can have any number of replication factor, that is not a problem. But see, if you think in a scalability purpose, I'll finish this. If you keep replicating it, then again it will take a storage space and all. And what will happen also, if one node goes down, this whatever the content, whatever the data which is present in the name node 2, it will name node will, sorry, data node 2, whatever that content which is present in data node 2 will be pushed or replicated in other nodes. Okay, so it will be always available. They will make sure the configuration is done in such a way that it is always available. Yes, Prakash, some. Again the replication, yeah, it will get replicated. Yeah, it will get replicated. Okay, some more details about FS image before. Okay, we will see some more information about the FS image. Okay. Okay, as I told, FS image contains the complete information about the complete file information about all the complete cluster. Okay, cluster I say complete setup, including name node, data nodes, and all other machines like yarn also will be yarn also is present in this, right? Resource managers, everything will be considered as the completed cluster. Okay, all the cluster file image file structure information where the data are present in the name nodes, everything will be present in the FS image. So it contains the complete information. Okay, but whenever any changes happen, changes in the sense, say I wanted to store this sample.txt, and now for example you imagine it is only of 128 megabytes. Okay, I'm going to store the sample.txt in node dn1. Okay, so this immediate changes or whatever is the current changes, that will always be written in edit logs. Okay, so first it will get written only in the edit logs. Okay, afterwards only it will get change, it will be updated in the FS image. Okay, merging of this edit logs into FS image will be taken care by the secondary node, secondary name node. Okay, what they are saying is, say for example, edit log and FS image is present in your data node, sorry, name node. Edit log and FS image will be present in your name node. 1 minute, I will take a slide. Discard this. Hmm. So if this you consider it as a name node, and name node will contain the FS image and the edit log. Any recent changes which is happening on your data nodes, adding of any files data or removal of the data or any processing information are all present in the edit logs only. Okay, then the secondary node, what it will do, and they also say like this, because it is not a like four nodes we cannot talk. Okay, see, data nodes can be huge number, any operation, any addition of a data, huge volume of data. If it is a live stream in the data nodes, you imagine that how frequently the changes will happen. It means that any change happens, it will keep adding into the edit log, the size of the edit log may increase. Okay, so for that reason only, what they will do, they will merge in the secondary name node. What it will do, it will take the FS image at frequent intervals, interval of 1 hour. Okay, this we call it as a checkpoint. Secondary node is also called as a checkpoint node. Okay, in every 1 hour it will pull the FS image file into it. Okay, and also it will pull the edit logs into it, and it will merge these two files, and it will give the merge the files, and it will give the fresh FS image. Okay, so s- in cases, say if a name node goes down, okay, you will not have this FS image, right? In that, what you can get is, you can take the FS image from the secondary node. You can take means whichever another node is coming into picture as a name node, whichever another node is going to work as a name node, will take this FS image because it contains the latest information, and from then on, latest file structure information it contains. From then on it will start working on this one, right? Because it we cannot lose the FS image, because this contains the information of where your files are present in your data nodes, right? So this is how it is working. So this secondary node name node will not work as a name node. It is not a backup node name. It is not a backup node for the name node. Okay, it is a, like a merger node, merging of fs image and the edit logs. It will keep merging it, because you cannot see the name node goes down, then you don't have the fs image with it, or nobody will have the edit logs here. So it is required that you have to keep a copy of this fs image and edit logs separately, and the merging is also happening in the secondary node itself. So whichever node comes up as a name node, whichever node we configure it as a name node later on, then that name node will have the latest fs image. Do you understand why do we have to have a latest image? Because fs image contains tells that where your data are present. Any client who are do wanted to do store your data, or wanted to do processing of the on the data, should know where your data is present, then only they can able to process it. Okay, this is one of the work of a name node. Okay, the process which you are seeing, no, name node process, we were seeing five processes, right? We were seeing five processes, like first one is the name node process, another is the data node process. So the name node process will keep this is what the name node process will do. It will keep updating the edited logs, and it will later on it will get the data from the fs image. That is what the main work of the name node. It will not store in a real time environment in your industry setup. It will not store any data at all. Okay, this will be only one node away, but in our setup we can have the name node as a data node also. That is not a problem, because we are only testing it. And one other thing is, where this value data are stored, fs image will be stored in the ram. Okay, you understand, no? RAM means it will be faster access, right? If you want, if the client who is connecting, client, when I say any map reduce job or any processing job which you are passing, okay, that will get easy, fast. That will get the data of where the data box are present. If the FS image is stored in the RAM, okay, easily it can get it. You understand, no? Like if it will also be stored in the disk too. Okay, disk in the sense hard disk. Okay, if it is in the ram, then the uh, getting the data from where it is present will be faster than when it if you are trying to search the uh, value from the hard disk. It means hard disk will have a seek time, you understand, because hard disk can be more also. So they will try, it will try to do a seek of your whatever the query you are asking it for, like the data blocks where it is present, the data information. Whereas a ram will be faster, it will work faster. That is the reason, whenever you are configuring a ram sorry, name node, the ram size of the name node should be higher. Okay, because all the activities of finding, accessing the fs image and even the edit logs will be present in the ram memory only. So ram will be higher. Normally when you configure your hadoop cluster, the name node ram will be higher than the data nodes. For the data nodes, data will be present in the disk itself. Okay, if you are trying to learn about this in anywhere, what they say is disk, they will call it as no, ram they will call it as in memory representation. Okay, in memory, that time you don't get confused. In memory means they're talking about the ram, not the disk. Ram, they'll say it as a in memory. So fs image, they'll say the updation of the in memory, they'll say. Okay, updation of in memory means once it got merged, you get a new fs file, the fs image file that will be updated again in your name node ram memory, and also it will be put in the disk. Okay, disk space also. Say if any crash happens, if name node is running, then you can pull the data from the disk itself rather than asking from the secondary name node. So this is how it works. Secondary name node is also called as the checkpointing node. Okay, and what else I have to say in this? Yes. No, see, in the configurations which you are giving it, right? The Hadoop cluster, when you are configuring it itself, they have the logic or implementation configuration to have a second name node also, secondary name node. If you see your processes, I will show you. Five processes will be running: name node process, data node process, secondary name node will be running. So what is the job of the secondary node? Every 1 hour it pulls the data from the FS image and edit logs. It will merge in its place and it will send back the FS image to the name node. That is the work of the secondary name node. Okay, and you will also have node managers and a resource manager. Okay, so this is all about these two. Let me see if I missed something. Okay, this is all about this. Any doubts in this one? No, right? Okay, and about the yarn, okay, there is one picture also I have put it to explain this. I think I have it here. Okay, this is about the working of a name node and the secondary name node. Both edit logs and FS image will be present in the name node. Okay, and as I told, these two missions, this name node, whichever mission you are going to keep it as a name node, and whichever one is the you are going to you are going to keep it as a secondary name node, will be of little higher end configuration. Okay, will be reliable missions. Okay, higher end configuration and will be of reliable missions, because those are very important missions, right? And the RAM size also will be more, because that is where the client will access all the data information from the name node. Okay, get the edit logs from the name node, get the FS image from the name node. Okay, merge edit log, I have missed it, edit logs and FS image. Okay, and make a new FS image. This is a new FS image, and that will be pushed back to the name node. This is what the working of name node. And so about the data node, so this you can have a pictorial representation. I take it somewhere. So this is how the data will be stored in the data node. Like master will have the information about file A is present. Okay, this is in this mentioned in this way. This file A is present in slave node 2, 4 and 6, and similarly file B is present in 3, 5 and 7, 4, 6 and 7. So this how it is going to be stored. They follow some algorithms. Okay, they are following some permutation combination algorithms. Based on that, they will store the data in the nodes. Okay. And furthermore, okay, about the resource manager, other two process, the other two processes are, where is it is not here. Okay, I'll clean this and write. Resource manager, initially before Hadoop 2.0, they had only map reduce job managers. Okay, map reduce jobs or trackers, likewise process is there. But when it is getting scaled, like when they were reaching a large amount of data, this is not working properly, so they have come up with a yarn. Okay, yarn will do the two processes, which is nothing but a resource management. Okay, and there is the node manager. These are the two processes. Okay, in the resource manager, okay, there will be of two things. Okay, that is the job tracker and No, it is not with the yarn, but normally what there are two processes which will be running internally and the task trackers. What does it mean is the job which the client is wanted to run, right? That will be given to the job tracker process. It's a process, okay, it will be running internally, and job tracker process, and this process divides this job into individual tasks. Okay. We will see it when you are running a Mac produce task. We'll say task that it will keep dividing the job into a individual tasks, and each tasks will go to the different node, data node, for processing. Okay. For processing means this will have, say for example, now in map reduce we will write a Java code. Okay, and that Java code will go to the data node 1. Okay, here we will have a sample file, a part of the sample file, and data node 2 and data node 3. That's what they say. Like in Hadoop, in the distributed environment, we move the processing to the where the data is present, rather than the data to the processing place. What does it mean? Say for example, I say that this is the distributed um architecture. Okay, data is present here. Okay, not data, this is maybe the master node. If you think it, data is present, data is present in all of the nodes. This everything you consider it as a nodes. Okay, and the processing, say we write a processing or it's some Java code. Okay, rather bringing the data into this to the one node, which is maybe a master node, you can imagine. Rather bringing into the master node, what they will do is they pass the processing to the data node where the data is present. That is easier. No, see, data is not very small. In our case it is very huge volume of data. If you bring it to a single node, then you have to think about the resources, and that is what happening in the traditional system, right? You will work on a single machine itself. You will bring your data which is already stored, you bring it for processing to a single server, and you will write queries and all, do any calculation on that. But that is not the activity in the distributed architecture of Hadoop, where processing means, say I written Java code, and we will generate the jar files. Okay, you will put the jar files in each of the data node, and there only it will process it, and all of this will be combined together, and it will give a aggregated results that we will see when we are seeing Hadoop. Okay, these are the activities of the job tracker and task tracker. So resource manager, what it will do, it will do the management. Resource manager process itself consists of two things. Okay, manager process consists of a application manager, and the another one is scheduler. So scheduler will schedule all the jobs which we are sending it to the from the client. Okay, to the where it has to mean schedule, it will schedule the jobs. So what it will do, that only it will do, right? Yeah, it will. Yeah, it will not schedule, it will also allocate the resources from the data node for running the jobs. Okay, allocate the resources means the resources are like how much CPU you wanted to run the job. I say like the processing. Okay, like if you wanted to find the number of words in a file, in this file, likewise that is the job we can say. So scheduler takes care of allocating the resources, and application manager, no, so whenever an application contacts for running any processing, the application contacts means, say the client. Okay, client can be any pig or any anyone outside the world, like MapReduce job are contacting the um, data node for doing this processing. The application manager will provide an id for each of the applications. Say if it is a map reduce job, then it will provide an id for the map reduce, it will provide an id for the pick, and it will application id. Okay, application id for the pig, and it will also provide an application id for the other clients whichever doing the operations. And it will also do other three activities like it will accept the request from the client. It will also write uh, okay, it will also provide the memory management. Okay, memory management of the slave nodes to the client. It means it will also allocate the resources. Hope this is clear. Yeah. Now last thing, no, okay, see, the other two processes I was talking. See, I will remove this, maybe I am confusing it, I think. See, the three other processes we have seen and what are its jobs we have found out. Okay, so there are other processes like a job tracker and a task tracker. Okay, it will, whenever you are going to do any processing on your data on the data node, these two will come into picture. That's what I was telling it. And there is a resource manager process. Okay, for managing your resources and accepting your request from the client, and run it in your data node. Okay, the resource manager itself consists of two other components like application manager. Application manager is nothing but the uh, application manager process. Okay, what it does it, when a client, or whenever, when I say the client who's sending any request for processing on the data node. Okay, because they will have the logic on the to process on the data node, no. So for accepting the um, client request, these are the job activities it will do. Okay, accepting the client request, delegating it to the proper node, delegating it to the data node, and assigning an application id, because which application it is running, no, all the application, many applications can contact the cluster. Not only that map reduce job will do, pig can contact the cluster, scoop can contact the cluster. For that it will assign the application id. Okay, so these are the jobs this application manager will do. And the resource manager, no, it is a scheduler, not a resource manager, scheduler. This process, what it will do, it will schedule the jobs. Okay, schedule the jobs to be run in the data node, whichever is running in the data node, that it will schedule. It will also allocate the spaces, or manages, rather than saying allocates, manages the cpu space, cpu times, or the ram space, memory space, how much it is allocated, all these things it manages, and it monitors also. Okay, this is what the job of the scheduler process and the application manager process. And there is the task job tracker and the tracker, which actually allocates divides your job into different tasks and sends it to the resource manager. Okay, I have a picture for that too, I will show it. Actually, I take it from outside. Actually, the resource manager will be present in the name node. Okay, job tracker, which will be present in the master node. Okay, that it will assigns the map reduce. No, it is present in name node itself. Okay, and the tasker only, the task which is actually going to be performed. Okay, when you take a map reduce job, okay, it does two activities. Okay, mapping and reducing, each we can say it as a task. Okay, task has to be performed on the data node. Why? Because the data is present on the data node itself. And many mapping jobs it can start, so many tasks it can run. Okay, so reducer also is a task that we will see when we are doing that one. Okay, this is like a overview of how it is internally happening. And the task tracker will also send like heartbeats, slots, and about the status information about its node to the master. Okay, so master will also have the information about the job which is running in the data node. Okay, for another one I have, okay, about this is the about the resource manager and the application master. Yeah, resource manager is holding the two components of application master and uh, scheduler. What it will happen is if any job is submitted by the client to the master, okay, resource manager will be running here. That it will create the first container. They will say the container means the space. Okay, space means allocating some space for running that job, that it will allocate. And actually it will contact the node manager. Then again resource manager and node manager I told, right? Resource manager and the node manager, two processes are running I told, right? In this, the resource manager will be running in the master node. Okay, and node manager will be running in the slave nodes, which are nothing but the data nodes. Okay, so node manager will accept the request sent by the resource manager, and scheduler will do other activities. Okay, and it will request resources from the scheduler. So scheduler knows about what are the, I mean, how are the spaces are allocated, that they will know, and it will give. Is this clear, guys? So it will keep going for every nodes. This is how it works. Resource manager. Okay, I will share one content here. I Okay, this I will share it. I'll share it in PPT also. So all this, these are the daemon processes which are talking. It is visible, no, no, right? Hadoop commands. These are the not commands. This is actually daemon processes. So all these processes are written in Java code, and it will be running as a Java processes. Okay, name node, data node, secondary name node, resource manager, and name node. In the master node, these three processes will be running, which is name node, secondary name node, and a resource manager. Okay, whenever the client contacts, it will contact the resource manager for running its job. And the slave node, it contains the node manager, and the node manager will manage the information or the about the data node. Okay, data node process also will be running it. Okay, so how the work will flow, this some examples is there. You can read through it. Okay, whatever I told. Node manager contains the metadata information about the complete structure in its memory. Okay, in its RAM it will store it. It will also store in the disk. That's what I told. Okay, whenever anything fails, the available nodes will be considered. See, we can also make a worker node also as a name node, as a master node, based on our configuration. Okay, whether this name node stores data, no, it will not store data. You can convert the name node as a worker node also. Slave nodes or data nodes, everything we can call it as a worker node. Okay, so there is also command. This is hdfs commands. This we'll see it late after this. HDFS commands like start, stop, the name node, and the data node is a slave system. Okay, it also always instructs the data node for storing of the data, whichever is coming to it. Secondary node, that's what here it is saying. Like after Hadoop 3, the role of the secondary name node has become less. Why they are saying like that is actually they have they are using the name node. They have advanced and use the failure rate of the name node as a reduced after Hadoop 3. Okay, that is the reason. If failure rate is less, then you don't have to use a secondary node name node at all, right? The name node itself will contain the FS image information completely. Only if failure happens, secondary node come into picture for taking the latest information from that. Okay, and the major functionalities I have told this. It is also called a checkpoint node. You can go through that. Then resource manager. It is called the global master. It is master daemon node also called. Okay, it has an application manager and a scheduler will provide the resources for the applications, okay, in order to run it, and responsible for accepting the request from the client and also the memory resources. It will manage it. Okay, it will allocate it to the client. And the node manager, it works on the slave machine, manages the memory information, memory resources in the node. Okay, and the memory disk. Okay, each slave node, whichever the data node you configure, how many ever thousands of data node even if you configure, each will have a node manager running that will keep track of the resources used. Resources is like memories, CPU cycles, and we see in task manager, no, if your machine is not working properly, which application is taking more space, all these things node manager will do. Okay, this is a small representation of, like, if a file you are having it as a.text and it contains 100 lines, and it is divided into blocks like b1 b2, each blocks divided. Okay, I told no, data are divided into chunks. Those chunks are called blocks and stored, blocks of 128 megabits and stored in your name nodes, sorry, data nodes. So if they are divided as blocks and stored in a name data nodes, okay, and the replication factor, if you give it as a 3, okay, how they can find it, how many ways you can replicate, how many ways they can replicate is in which are the combination you can replicate. Okay, that they will arrive at a calculation. This is maybe simplest calculation. Likewise, they may have different algorithms also internally, but here, like, 5c3, it's a combination. Okay, so 5 factorial into 3 divided by 3 factorial into 2 factorial. So 125 factorial is 120 by 12. 10 ways you can store the mm, data, okay, in 3 nodes. Sorry, 3 data. If it is divided into of 3 blocks, you can store that in 10 ways of in 5 nodes. Okay, is it clear? Please tell me. I'm just talking. This one is clear. Okay, you can 10 ways means like in node 1, node 3, node 4, node 3, node 1, node 3, node 4, you can store node 1, node 5, node 6, node 2, node 4, node 6. Likewise, you can store it in 10 ways. Okay, 3 blocks of data. Okay, till now is it fine? Slave node, slaves. Slave is a machine and data node is these are something I have written. We have written it. It's okay. You can ignore it. This is not required. And the slaves are the node itself is called as a slave node. Okay, but the process which is running inside the slave nodes are the data node, and one other is node manager. Is this okay, guys? Master is name node and the data are slave nodes only. The process which yeah, just you can ignore it. What you can say interchangeably as slave also as a name data node, you can say slave is also a data node or data node is a slave. Interchangeably we can use the words. Is this okay till now? And the port which is defaultly where these processes are running is 5070 for the data node. For the secondary name node it is 4090. Okay, resource manager is 8088 and node manager is 8042. After installing all this, you can open the your cluster in a browser. That day I showed, I think, in the port 9870. I'll show it now also. And you can browse through your cluster. Okay, you can see the data nodes are configured. You can also save your files into your hdfs. Hdfs is the file system, right? There you can store your data in that also. Okay. Okay, let me know, is this okay now? Then I will move on. Okay. Okay, then I will open my VTE lab. So everyone installed a cluster machine, I mean single node, right? Were you anyone ever anyone facing difficulty in that? Completed the installation, no? Amalan, did you finish installation? Mahalakshmi, Manigandan sir, Prakash, Maria, Saurav, Venkana Babu. Finished it. Okay. Okay, then I will. What is error getting your? You will rectify it. What is the problem coming, Maria? Can you tell me? Okay, fine. Okay, now I will show how do we traverse the Hadoop cluster. We have a yes, I will say it in the end of the class. We can traverse through the browser. Okay, the administrator, like this is installed in the local host setup. So local host, the port to open the Hadoop cluster in the browser is 9870. Okay, enter. It is not opening, unable to connect. It is saying unable to connect. I think the processes are not running. JPL will show the process. It is not running. So I will start it. Okay. Start hyphen all dot sh. Hope you remember that day I told like start hyphen all. What all it will start? It will start the DFS and it will start the yarn. Yarn is actually the resource manager and the node manager. Okay, and you have to whenever you are doing name node format hyphen name node format, right? Yeah, hdfs name node format, then it will actually create your initial fs image, because fs image will not be present. Okay, it will have the initial picture of your file structure, and so that is the reason you have to do a format, and that is a one time activity. You will not do it every time, that one, as I told. Why? Because if you do it, it will format your fs image file. It will clean it up, clean it all. And you imagine if you are working in a setup, then nodes data are present in your data nodes, and the fs image is having the information about it, right? Then anyone who is running any client or anyone who is running the job will not understand where this values are present. That's the reason you will not format it anytime. Okay, if you are formatting means you will lose the information of where the data are present. Okay, I'll start the process. Okay, now we will see all the processes are running in this. Okay, and okay, I wanted to show the browser. Now I will connect the browser. So it is showing the name node information. It is the administrator. Okay, it contains about the block pool ID, all the information. You can dig in through what are all this later on. Okay, DFS is actually a shell. Okay, DFS a shell means a shell scripting you are using, right? The bash shell and all that, it allows you to do some programming, right? CLI they will call command line interfaces. It means you will run the commands in the terminal. Okay, likewise a bash shell you have uh, other many shells are there, no, which is famously now used as secure shell used there. So in that way, DFS is a shell in Hadoop for writing your commands in that. Okay, and it is saying the live node as one. Okay, decommissioned and commissioned is like it is see you keep adding many data nodes in your cluster machine. Okay, say later if you wanted to remove a node from the cluster, so that time this you can do a decommission of the nodes from the cluster. How we can do it? There is a there is hdfs or dot node in the hdfs site.xml file. You can give a configuration. Okay, I'll show it later on. You can change the configuration and remove one node, okay, from being live or being used for any processing. Okay, decommission one will only remove the node from the cluster. Okay, it will not make the node down and all. It will it can be running also, so it will not make the node down. It will only remove from the cluster. Okay, the node can be running, and node, whenever I say, it can be any computer machine which can be running, or any server which can be running only. Okay, and dead nodes we don't have anything. Say when we do a multi-cluster installation, you can see that the live nodes 3, all those things. If you do a decommissioning by ourselves forcibly, that remove a node from a cluster, then here it will have the entry as 1. Likewise, okay, total data node volume failures, we don't have anything in that. Okay, data node is this only one data node we have. And about the journal status and all, and the disk capacity, okay, storage types and the capacity also, which how much it is used, all this information you can see it from here. And about the data node also, it has the master itself. Here we have configured as a data node, right? That's why it is showing Hadoop master only. Okay, and if it is more number of nodes, each one will come in here in the line. Okay, then the status, capacity, everything you can see. This is 100 GB machine. Okay, master is an 100 GB machine, so it is having 97, that more or less approximate disk space it is showing here. Okay, maintenance, decommission, data nodes, everything it will come here. And furthermore, you can see volume failures. Volume means the data, the data which is stored, that failures. Snapshots, startup processes, so processes information, the edit logs, which are we are seeing the fs image information, all these are present in this. Okay. Okay, and the utilities will have, you can browse through the file system, browse through the file system of the HDFS. Here nothing is there. If you put any data into the HDFS, then you can see it. What are the information present? It will be stored as files only, right? Okay, like our Linux machine, and logs, other things you can browse through. Okay, so these logs also you can see it here. That day we were seeing no name node logs, data node logs, that you can see. Any error comes or any processes is not up, you can see the logs here, or you can see it in your machine itself, in your where you have put your Hadoop user user local, there itself you can see the logs. Okay, etc logs, Hadoop logs will be there. Here you can see same thing will be here. Okay, it is all updated. Then Then now we will do some HDFS commands. HDFS, I told like it is a distributed file system for storing your data. See, you go to root, okay. In root you see many things. This is a root, right? Root directory, and you see many things, no, many files stored. Same likewise, the HDF files also will store the data. Okay, so in order to store or access, there are different commands you have to use, and the DFS shell you will be using for doing that. Okay, I will share another PPT. Okay, this is about HDFS commands. So this is how you can start. You can start writing the commands like HDFS, DFS or Hadoop FS. You can do anything likewise. In order to say that you are going to store the data, LS is a list, right? Same thing you can have it in your Hadoop FS commands also. LS, it will list the files in the Hadoop directory, Hadoop file system, not in your Linux. Okay, and this will list in the particular from the particular directory. Okay, ls hyphen d directories. It will list the information about the particular directory, and hyphen h will tell about the file size in the directory. Each one I will show. Okay, mm, append to file. Okay, everything I will show one by one. You can write down these commands or you can refer it from the PPT itself. Anything is fine. Okay, so how do we do Hadoop fs hyphen ls, the root, this is the root directory. Okay, it is going to list your file system from your HDFS. There is no content in that, that is the reason it is not listing anything. Or you can also use this one, HDFS DFS hyphen ls, sorry, root directory. It is not having anything, both are same, but normally HDFS during administrative commands they use it. Otherwise you can use anything interchangeably. Okay, HDFS DFS or FS. Say I wanted to put a file or write a file into your HDFS. You cannot write any files, you cannot open any files and write it in HDFS. Okay, you can only directly transfer from outside to the to the your HDFS into your file system. Okay, say pwd, I'll go to home nylet cd documents. I will have a sample dot txt file. Okay, in that I will write hello class. It is already there, one sample file, hello class. So I wanted to put it in the HDFS list. So what is the command is Hadoop fs hyphen put. Okay, from where? From my particular directory like home nylet documents sample.txt, that dot text to where. Okay, this is the source directory, source file. I have to put it in the root directory. Okay, I will put it. Okay, if now I'll try to list it and see Hadoop fs hyphen ls. There's some problem in the mouse. Hyphen ls um, slash, I listed the root directory. Now it is, see how it is showing same like our file system. Okay, that is why we say that Hadoop is a distribute file system. It is not a database. Okay, it stores the files in the form of files only, same like a Linux file system only. Okay, sample.txt is present in the root directory. Okay. Okay, so similar commands you can use of Linux commands itself to write or make directories also. So we can make a directory and put some files in that and see. Just a moment. Okay, I will make a directory. Same commands. Make directory command fs hyphen make directory. Okay, then I will say a directory like in our root we wanted to make a directory like a demo. Okay, demo directory it will create. In the root of hdfs it will create a demo directory. Okay, you can list it and see. Okay, it has a demo directory, you can see this one, right? D is for a directory, right? And this is the file which is present in the hdfs. Okay, and something else is like if you want to preserve the permission for any file from your local, see we are transferring from our local to your hdfs, right? Say I have some file, program 1.txt, I'll take it, I'll change the permission of it to 777 program 1.txt. Okay, so now the file permission is changed, this one. So in order to preserve the file permission also and save it in your hdfs, then you can use this command like -p. Okay, so Hadoop, even I forgot it, that's why I'm seeing it, what I've written. Hadoop fs hyphen put hyphen p, from where you wanted to put. We are in down documents directory only, so directly I'll give program 1 dot text to slash demo. You will put it in the demo folder. Okay, in hdfs. Enter. Please note down these commands, but they are in ppt itself, so it's okay. Okay, it is there. Then I can list it and see Hadoop fs hyphen ls. So I wanted to directly list contents of a demo directory, then I will give it like this. Okay, so it is saying the permissions also are preserved and it stores the value here. Okay, see we cannot do a vi on the files. Okay, we can only view the files in the hdfs. Vi means we cannot edit the files, we cannot view in a editor, any editor, nano editor or vim editor, that you cannot do. You can only view the contents of the file using the cat command. So Hadoop fs, if we want to view the content of a program 1.txt, then we have to give cat like a demo slash program 1.txt, so that it will list it here itself. It is saying this is a data science class. Okay, I think this is having some other content also. Okay, this is what it is displaying. This is the content of that file, I think. vi program 1.txt. Yeah, this is the content of the file. So whatever we have transferred to our hdfs, it is showing. Okay, one by one we will do many other things. cat I have showed, and there is a something like copy. Okay, there are three things are there: copy command, cp command, and copy from local command, and another one is a move command. Okay, so each will do different activities. We will see what it will do. Okay, I will come out of this in hdfs. Say I wanted to copy a file. Okay, copy a file. Now I will copy program2 dot text. Okay, so how we have to do it? No, it is not copy that one. So go to hdfs fs hyphen ls list. Okay, list is showing the directory and the sample text. Say I give a hyphen r, capital R, recursively. Okay, it will gives the data inside. See all the files like demo directory is there, demo program on text is also there. Small r also you can give. Okay, recursively it lists it. So what I will do, I will use a copy command. Okay, copy Hadoop fs fs hyphen cp. Okay, copy sample dot txt to demo directory. Okay, now you have seen where the sample is present in the hdfs. Okay, now I'm copying sample.txt to demo.txt. Enter it. So when I list it and see, can you see this sample has come to the demo directory also. Okay, there is a difference between cp and c copy from local. That's the difference I wanted to show. Initially sample is outside the demo directory, right? Now sample is also copied to demo directory. Can you see the difference? Please tell me. One other thing I will show. Okay, now Hadoop fs hyphen copy from local. Okay, local copy from local. Here I will copy program2 dot txt file into demo. Okay, demo of hdfs. Then now I will list it. So program 2 is copied to demo folder. Please tell me what is the difference you are finding it here. No, this is the copy command, and this is the another copy from local command. Can I again make it? What I will do, I will first put this buffer.txt is there. I will put this buffer.txt in Hadoop. Okay, fs hyphen put is the command to put any files into hdfs hyphen in the root directory. I will put it. It is saying no such file. Okay, hyphen put which file I have not given. Buffer.txt. Okay, I have put this one. Okay, it is put. Now I will display it. Hadoop fs hyphen ls slash in the root. Okay, now buffer.txt is there, okay, in the root directory. Okay, now I am not in documents folder. Okay, I will come out of this. Now I am in a nihilate folder. Okay, think of that. With the copy command, what I'm going to do, uh, eh, Hadoop fs cp, okay, slash buffer I give, buffer.txt, into demo folder I will put, okay, in the hdfs. See what I'm writing here, okay, slash buffer.txt I'm giving into demo. Enter. Okay, now I will list it. Hadoop fs-ls slash, it contains buffer.txt, no problem, but I have copied buffer.txt into demo, right? We'll go to demo also and check it. Okay, uh, list list in demo. Okay, okay, in demo also it is there, buffer.txt. Now tell me, buffer.txt is copied from which location into demo? With this command, buffer.txt is copied from which location? Root. Root means where? Which root? Actually, what it is doing is it is copying the contents inside the HDFS itself. Root buffer.txt is present here, right, in the HDFS. It is not taking from the local, my Linux machine, it is not taking. Okay, it is taking from the HDFS itself. It is copying from the root HDFS into demo directory. Okay, I'll write one more command here, then it will be more clear. If I do a move mv, okay, root directory to demo. Okay, this is already existing. So what I will I will copy another folder. I'll put a buffer one.txt is there from downloads. Okay, it is not there. Documents, I think. Okay. Now buffer one.txt, I put it in the root directory. Okay. So I will list it. Recently I have put buffer one.txt. Okay. So what I will do, Hadoop fs-move slash buffer one.txt to demo. Okay, buffer one.txt is in the root directory. Now I'll move it to demo. Now we will list it and see what is happening. See, it is not there in the root directory, right? Buffer one.txt is not there in the root directory because I copied from root directory to moved it from root directory to demo. So we'll go to demo directory and see whether it is present in that. Okay, it is present in the buffer one.txt. So both move and copy, right? Copy, you cannot see the difference. Why? Because it is not moving. Here both move and copy, what it will do, it will transfer your files inside your hdfs itself. Okay, so if you wanted to copy the values from the local, okay, you will use local means copy from local, then I'll say home, Nilet, download something I will take. What is there in downloads? Say for example sample.java. Okay, I'll take a sample, sorry, sample.java to your HDFS file system root directory. Then you can give it the copy from local. You found you got the difference. No, now you can see, list it and see it. In the root it will be there. So copy from local and move. That difference you got it. No, Saurav, you got it. Others, Amalan, everyone left. Why you people are leaving? Couldn't attend the class. Okay, no problem. Okay, this is about put get get is also there that copies the file from the HDFS to your local machine. Okay, that is also possible. I will show one command in that Hadoop fs hyphen get from your say I take buffer. You cannot tab it because it doesn't understand. Buffer to my home Nilite. Okay, downloads. I'll put it in the downloads. Okay, this is also possible. You can get it from the HDFS and put it in your downloads. You can list it here. You go to home, Nilite, downloads, ls-lrt. The last recent will come in the down. Okay, September 16, 1556. These are case sensitives. Commands are not case sensitives. No, commands like Hadoop, fs, hyphen ls. Capital Ls and all will not work, right? Command not found. It is case sensitive only. You cannot do that. Okay, put is fine, right? See, actually, whenever you are accessing the file system in HDFS, you use this command, right? Yeah, Hadoop FS command. So this command, using this only, you will understand like we are accessing the Hadoop file system or not. Okay. Uh, then what is the doubt? That is a move. Move command will copy one directory, one file from your HDFS and put it in another file in HDFS itself. It will not take from your Linux machine. That I put it, not moved, because file is not there. So I put a file to show the. Yeah, we can only copy it. Why do we have to move from our local to there? We need any files in your HDFS because we want to do some processing on the files, right? It doesn't make sense moving from here and on there and on. Moving within the file system makes sense, right? From one place to another place. Okay, this is about a get. Remove is also there. You can remove a file using recursively. Okay, I'll show that. Yes, Maria, it is case sensitive. Copy from local is case sensitive. You have to give like that only. H Hadoop fs hyphen remove directory or remove a file like a sample.txt we put no in the root. That is also allowed. You can remove the file also, and you can create a file using the touch command, right? Touch zs, same file I created. I removed the file. touch is at, it will give, it will create a file with a zero length. Okay, because there will not be any length, you can list it and see Hadoop, or you can also give this command hdfs dfs hyphen lsl hdfs hdfs. Okay, I have created a file, right? It is of with zero size. Touch will create a file in your hdfs. Touch is that. Okay, and what else is there? You can change the permissions also to the files. Same way, you can change the permission. You can change the ownership, username, and local name. Okay, only this I will show. The rest we can see it on Monday, I think, because you people have left. Safe mode and all, I will show it on Monday. Okay, one more thing is that DFS command I have to show is like a Hadoop DFS. Okay, first this I will finish. No, both are same only. But normally when you are running administrative commands, you will use HDFS. Okay, uh, wait, HDFS, DFS report. I think I forgot the command. In order to see the report, you can use that. This is not that one. Okay, HDFS DFS admin report it is. HDFS DFS admin report hyphen report. I think yes, it is hyphen report. Yes, right. Thanks. This will give the information about your notes. Okay, live notes. Here there is only one live data nodes. Okay, and the master node information about replicated blocks. There are 7 replicated blocks. Whatever we have written, no, all the files that it is giving. Fine, and the DFS remaining space and all information. The status amount about status information about your nodes it gives. Decommission status is normal. It is not removed from the cluster. This node. Otherwise, it will give it as a decommissioned. Okay. Okay, I think I will stop it here. I will show the rest of the comments where replication, you can set a replication factor also. You can change it. Okay. That means the files which we write in a HDFS, right? That you can say how many times you wanted to replicate. To that you can set it using the commands that I will show when we do a multi-cluster. I think next week we'll do the multi-cluster also. And what else is there? Some of the report commands. Okay, you can refresh it, open it, and about the there is a df-h command is there, no, in your Hadoop, sorry, in your Linux, which shows the status of your memory and all. These commands also you can use it in Hadoop. fs-df slash the status about the size used and all this information it will give. Hyphen h will give it in proper format like a GBs. Likewise, it will give. Okay, 70 GB used. Size is total size is 97 GB. Available is 70 GB likewise. So some more we will see it on Monday. That is all for now. And please do lab exercise in MySQL. Okay. Okay. Any doubts you can ask me. Otherwise you can leave.